Alright, this is the 4.4c worksheet. Number 1, factor the expression. We're going to check a few things. We're just going to do them verbally. I'm not going to write down order and GCF and all that stuff, but we will talk through it. First, check to make sure the order is good, and it is. You're all set. The next thing, check for the greatest common factor, or check to see if the lead coefficient is negative. The lead coefficient's negative, so what we want to do is we want to factor that negative out. So we're going to have x squared minus 3x minus 40. At this point, keep the negative outside, and this is an easy trinomial, so we're just going to use trial and error. To get the x squared, you need x and x. Factors of 40 that when multiplied give you negative, or when added give you negative 3. That's going to be 8 and 5, so negative 8 and positive 5. That's your answer. Number 2. The order is good. There's no greatest common factor, and it's not a special pattern because the first term is not a perfect square. So we're going to do the box method here. Okay, now let's drop in the first term here, last term here, multiply the a and the c together. 3 times 36 is 108. You can write down all of your combinations. 2 and 54, 3 and 36, 4 and 27, 6, 18, 9 and 12. The middle term is made up of x's, so we'll just figure out the combination first and we'll make sure that we put x's. Let's read the signs. Both are going to be the same sign. They're both going to be positive. So if I put positive all the way down, and the combination that adds to 31 will be this one right here. And remember, they're made up of x's. So let's drop in 4x and 27x. So it's going to be positive all the way around. So let's put those. Let's factor out here. The greatest common factor between those two is 9. The greatest common factor is x. Over here you'll have a 3x. Over here you'll have a 4. So it's going to be 3x plus 4 times x plus 9. And that's an answer. Alright, over here the order is good. There's no greatest common factor. It looks like it might be a perfect square trinomial. Let's check. 4x squared as a square root is, or the square root of this is 2x, the square root of this is 5. Is 2x times 5 half of 20x? Yes, it is. So it's a perfect square trinomial. So drop the 2x in the first, drop the 5 in, and take that middle sign and put it right in the middle, and you're done. 2x minus 5 squared. Alright, number 4. It's in good order. There's no greatest common factor. Actually, no, wait a minute. There is, sorry. The greatest common factor is 3. So let's factor out the 3. So we'll have k squared minus 8k minus 9. That makes it an easy trinomial. So we'll do the 2 parentheses. K squared, you're going to have k and k. Factors of 9, 1 and 9, 3 and 3. Different signs, the larger is negative. Well, you really can't say one is larger than the other over here. But it doesn't make a difference because that's not going to be the answer anyway. If this was the answer, then it would be a perfect square trinomial. So it's this one. So positive 1, negative 9. And that's your answer. Number 5, the order is good. There's no greatest common factor. But it is a perfect square minus a perfect square. This minus makes all the difference. So the square root of y squared is y. The square root of 4 is 2. So it's going to be y plus 2 times y minus 2. Number 6, this is going to be a temporary solution, or sorry, temporary substitution problem. So we're going to let 2x minus 3 be k. So we're going to have 3k squared plus 17k plus 10. Let's use the box method. First term 3k squared, last term 10. We want factors of 30. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. Both are the same. They're both positive. Which one adds up to positive 17? It's this one right here. Remember, they're made up of k's. So when I put the 2 in, it's going to be 2k. When I put the 15 in, it's going to be 15k. Positive all the way around. And then factor the GCF. So there's a 5, a k, 3k, and 2. So we have 3k plus 2 times k plus 5. Now remember, k equals 2x minus 3. So what we're going to do is we're going to substitute 2x minus 3 in for k on both parentheses. When we do that, we use parentheses. It's important. So 3 times 2x is 6x. 3 times negative 3 is negative 9. Plus 2 is negative 7. Over here we have 2x. Minus 3 plus 5 is plus 2. So this here is your answer. Alright, number 7. Let's determine the vertex first. The vertex is going to be negative 2, comma 3. They want the axis of symmetry, so that's going to be x equals negative 2. It's opening up, so it's going to be a min value of 3. The domain is all reals, and the range is the set of all y's such that y, it opens up so it's greater than or equal to the min value. And that's it. Number 8. This is when you're finding a quadratic model, so let me get the calculator out here. Let me move this over first. Okay. Let's turn it on. Hit Stat Edit. Clear your lists if it's not. And let's plug in the x values. So 0, 5, 10, 15, 20. For L2, we're going to have 17, 39, 54, 61, and 61. So hit Stat, go over to Calc, 5, go down to Calculate, Enter, and you have your A, B, and C values. So let's write those down. The A value, let's write them here. The A value was negative 14857. B was 5.17. C was 16.97. So write this out as a function. So f of x equals negative 0.14857x squared plus 5.17x plus 16.97. And you're done. Number 9, rewrite it in vertex form. So we need to find the vertex. So it's in standard form, so we're going to do the opposite of b over 2a, which is 2/6 or 1/3. So that's your x coordinate of the vertex. So I want to plug that back in to get your y coordinate of the vertex. So we have y equals 3 times 1/3 squared is 1/9 minus 2 times 1/3 is 2/3 plus 8. 3 times 1/9 is 1/3 minus 2/3 plus, let's make this thirds, so it's going to be 24/3. So 1 minus 2 is negative 1. Negative 1 plus 24 is 23. So 23/3. The axis of symmetry is x equals 1/3. This is your answers. And number 10. Explain in words how to tell whether a binomial can be factored as a difference of two squares. Remember, a binomial that's a difference of two squares looks like this. So a couple things has to happen. You have to have a perfect square for the first term, a perfect square for the second term, and a minus sign in the middle. So if you have a perfect square minus a perfect square, then you know that the binomial can be factored as a difference of two squares. And that's it.